In this video, we'll just look at how we can tell a function is trigonometric by its table. So if you look at the table here, we can see some patterns developing. For example, we can see that the number 2 appears a whole bunch, as does the number 0. So here we've got 2 appearing a couple of times. We've got 0 appearing a few times. And we have -2 also kind of appearing a couple of times. So that's sort of indicating that this is probably a periodic function, a function that's going to repeat. And again, we can verify that by graphing it. So let me just clear that stuff out of here. Go ahead and verify by graphing. So I'm just going to plot these points 0, 2. When x is 0, y is 2. That's right up here. When x is 1, y is 0. When x is 2, y is -2. When x is 3, y is 0, and you can start to see that trigonometric function starting to appear. When x is 4, y is 2. When x is 5, y is 0. You can see it's repeating again, right? 6, it's -2. And when x is 7, y is 0. So we can draw this with a nice smooth curve, kind of connecting our points. I won't really do it justice here, so we'll just have a look in a second to see what it actually should look like. And then from here, we could read off some key characteristics. So we can tell where the x-intercepts are. The x-intercepts are where the y values are 0. We can tell where the y-intercept is. So these were all x. Sorry. Let's try that again. These were x-intercepts. I'm having trouble with my pen. There we are. The y-intercept was up here. And a couple other things, the maximum value. You know, if we were trying to find the maximum value was 2. It happens, in a bunch of different places here, and well, I guess it would continue there. Those were all max values, and the minimum values are down here. And then we can also list off the domain and the range. So the function itself would have a domain where x is an element of the reals. And a range, so that was the domain. Maybe just use the letter D here. And the range would be that y is an element of the reals, such that y is between -2 and +2. So -2 is less than, or equal to y, which is less than or equal to +2. We'll just include that as a set. So, but if we wanted to know just the domain and the range from the table, and that's it, the range wouldn't change, but the domain would be that x goes from 0 to 7 by the looks of it from that table. And here's what the graph should actually look like. A little bit cleaner. Maybe we should have done the work there, but you can kind of see that shape appearing. All right, now that was an easy one. That one where the sinusoidal axis was right down the middle of the function. That's not always going to be the case. So let's have a look at an example where that's not the case. So again, here are some x and y values. When x is 5, y is 2. Put that on the graph over here. When x is 9, y is -1. When x is 13, y is 2. When x is 17, y is 5. Way up here. And then finally, when x is 21, y is 2. So you can see that sort of similar trigonometric shape developing. And this time, the axis is not centered on the x-axis. The sinusoidal axis is not centered on the x-axis. So we get something that looks like this. And again, we could read off some features. It would have some intercepts. I'm going to just show you what the actual graph looks like because that's a little bit easier. We could read off the intercepts. And again, we would have to estimate these. If you look at them, you can see they're not whole numbers, but we could estimate what these intercepts are. So what's that? A little bit less than 7 and a little bit more than 11. We could find the axis. Remember, the axis is halfway between the max and the min. So we can find the amplitude here. We can see that we go from a y value of -1 up to 5. So that's a difference of 6, which means that the axis, should be up 3 from the bottom. So 1, 2, and 3. So our axis, I'll just get a line tool here, should be in here. And that will allow us to find the amplitude. So you can double check. The amplitude looks like it's 3. So 3 from here to here, 3 from here to here. So we've put our axis in the correct place. The period of the function is how long it takes for one complete cycle. So one full cycle starts here and finishes over here. So we can see that that goes from 5 to 21. We do 21 minus 5. And that will give us a total of 16. So the period there would be 16, whatever the units are here, days, seconds, minutes, or something else. So that's how we can use a graph and certainly the table to determine some of the characteristics of trigonometric functions.